And so in this lesson, we're going to continue focusing on simplifying the rational exponents, but now including multiple expressions, multiple bases. So we're adding on to that previous lesson here. So in this case, again, before we get started with rational exponents, just review with our exponent rules. So keeping in mind when multiplying, right, we're going to add the exponents, but the bases must be the same. So like here, for example, I have x and I have x. Remember now, if x is here by itself, it does have that exponent of 1. So we are going to add these two exponents. So again, when multiplying, we add. So this is x to the 6th, then times y squared. Now, can we combine now because we're multiplying and add the exponents and say 8? No, because the bases are different. This has a base of x, this has a base of y. So again, bases must be the same. So then here, think about like order of up, right? We're going to do the parentheses first. Now the bases are the same, they're both x. So I'm going to go ahead and add my exponents. So this is x to the negative 17, still raised to the second power. So now that power to a power, think about the parentheses, right? So whenever we have a power to a power, parentheses, that means multiply. So negative 17 times 2 is negative 34. Then again, negative exponents, we rewrite. So we're going to flip that base here. So this is 1 over x to the 34th power. And then so same thing here. Now notice up top we're multiplying, but are the bases the same? No. So we can't add these and say 17. Same thing in the denominator. However, the bases are the same in terms of numerator denominator, like we're dividing. Remember the rule when dividing, top to bottom. Subtract the exponents, keep the base. So this is 2 to the 10 minus 12. We're taking the exponents and subtracting top to bottom. So then for our base of 4, so what two exponents are we going to subtract for our base of 4? 7 minus 5. So now here we've got 2 to the negative 2, right? Because that's 10 minus 12, and 4 to the second power. Now, is this our final answer? No, because we have a negative exponent here for the base 2. So our final answer is 4 squared over 2 squared. Now, we could also practice continuing simplifying because 4 squared is 16. 2 squared is 4, and 16 divided by 4 is 4. So here, go ahead and pause the video now and try these 3 U-try problems on your own. And here we go. So here now I've got my bases that are the same when dividing, not multiplying. So we can't add the exponents, but top to bottom, subtract. So this is 6 to the 8 minus 6. Then for the base 3, you have an exponent of 1. So this is 3 to the 1 minus 3. So now here you end up with 6 to the second power and 3 to the negative 2 power. But this is not our final answer because of the negative exponent. So here you've got 6 squared over 3 squared. Now, you could have also continued simplifying, right? Because 3 squared or 6 squared is 36. 3 squared is 9. 36 divided by 9 is 4. So then here, now we are multiplying, so we need to add the exponents. However, you can't add all of them, only if the bases were the same. So this b to the first power, and then add to that the exponent for b to the 9th. So bring down, this is a to the 3rd times b to the 10th power. Then here, focus on parentheses first. So notice bases are the same, so we can add our exponents because we're multiplying. So this is 8 to the negative 1, 2 plus negative 3. Then raise that to the 4th power. Now notice here you have a power to a power, so parentheses, think about multiplying. So this is 8 to the negative 4, which rewritten 1 over 8 to the 4th power. So now we're going to get into our rational exponents. So again, are the rules going to change? No. We're multiplying, but we can't add the exponents because the bases are different. But we're dividing, bases are the same, so we're going to subtract the exponent. So again, top to bottom. So we're going to subtract what two exponents for x here? 3/4 minus 1/2. Then here for our y, base of y, we have an exponent of 1. So 1 minus 2, right? Top to bottom. So now here, if you're struggling with the fractions, you can put that in the calculator, all right? You end up with x to the 1/4 power. Then here you have y to the not 1, because this is 1 minus 2, so negative 1. Now, is this our final answer? No. Why? Because we have a negative exponent. So this is x to the 1/4 power over y. Now, you could put y to the first, but it's understood when y is here to have that exponent of 1. So again, same thing here. When multiplying, bases must be the same in order to use the exponent rule. So like this is a here. We're going to add the exponent. So negative 1/2 plus 4/2. You have a to the 3/2 power, then times b to the 5/2. Now, can we combine them? No, because the bases are different. So go ahead again, pause the video, try these two U-tries now on your own. And here we go. So again, you should have noticed when dividing, bases are the same. So again, subtract, but top to bottom. So for the base 2, 2 minus 5. And here for our base of 5, you have 4/2 minus negative 1/2. So notice, write it out, because you'll see that that's not going to give you 3/2. Because two negatives here make a positive. So you actually end up adding them. So here we've got 2 to the negative 3 power and 5 to the 5/2 power. Because again, that was 4/2 minus a negative 1/2. So you got to watch your signs here. Now, is this our final answer? No. Because of the negative exponent, we have to rewrite. So this is 5 to the 5/2 over 2 to the 3rd power. Then here, we're multiplying, so when bases are the same, we add the exponent. So you should have noticed your two g's here, so only add these two exponents. So this is g to the 3/5, then times h to the 9/5. Final answer, because bases are different. So now we're going to include our rules, but now also rewriting. So again, notice here, we need exponential form. However, this isn't a radical, so rewrite it, right? This is x to the 4th power. So this is x to the 4th power, but over what is the index for the radical? 5. So over 5. So remember, that's x to the 4/5 power. Then bringing down y to the negative 2. And if you want to bring down, go ahead and bring down that is x to the 1st power. So now that we have everything rewritten, what can we combine? The 4/5 and 1, because the bases are the same. So 4/5 plus 1, be careful, that's not like 5/5, because then you're saying this is a fraction here. So again, if you need to, use your calculator. You get x to the 9/5, then times y to the negative 2. However, is this our final answer? No, because of the negative exponent. So this is x to the 9/5 over y squared. So then here, notice again, we need to rewrite the numerator. So I've got b to the 5th power. So b to the 5th power, but over what is the index? 4. So 5 over 4. Now notice in the denominator, you're raising a power to a power. So again, parentheses, what did we do? Multiply. So that is 3 times 1/4. So that is b to the 3/4 power. Now notice we're dividing and the bases are the same. So what do? Top to bottom, subtract. So this is b to the 5/4 minus 3/4, which gives you 2/4, or you can write this as 1/2. Now, if you wanted to rewrite this as a radical for practice, you would say that this is the square root of b. That is the same here. Now, for those who are wondering, actually, let me explain how this is the same, because that is b to the first power. So again, b to the first power, and then inside of the index here is 2. Remember, a square root has that understood index of 2. So that's why it's the square root of b. Go ahead and pause the video and try this you try on your own. And here we go. So you should have noticed here, this first one, you needed to rewrite. So this is x to the second power. So x to the second power, then over your index of 7. Then I'll bring down all of our other terms here. So now only adding exponents where bases are the same was only these first two here because they had the base of x. So this is x to the 5/7 times y to the 5/7 as well. And this is your final answer, no negative exponent. So then here up top in the numerator, let's rewrite. So that is c to the 4th power, then over 9, your index of 9. Then in the denominator, you are raising a power to a power, so multiply 7 times 2 ninths. You now have c to the 14 ninths. Now notice bases are the same and we're dividing, so subtract the exponents, right? But top to bottom. So you should have done 4 ninths minus 14 ninths, which gives you not 10, but negative 10 ninths. So now because of that negative exponent, your final answer is 1 over c to the 10 ninths. Now, if you wanted to practice rewriting, that is 1 over c to the 10th, right? So c to the 10th. But inside of, what is the index for your radical? 9. So now, if you notice, there are some practice problems. So I would suggest, again, pausing the video, try these practice problems, and then I'm going to quickly go through these in the video so you can check your answers. All right, so here we go. For the first problem, you just have a power to a power, so you were supposed to multiply 4 times negative 1/2, which is 3 to the negative 4/2, or negative 2, which is the same as 1 over 3 to the second power. And then for those who took it a step further, this is 1 over 9, 3 to the second power. So then here, bases are the same. You add the exponents, and that exponent of 1. So when you add, you end up with x to the negative 1/3. Again, negative exponent, so 1 over x to the 1/3. Then again, for those who practiced rewriting, this is 1 over the cubed root of x to the first power. So leave it as is. Then here, you're multiplying, bases are the same here, so add the exponent. So this is y to the 1/3. 2/3 plus negative 1/3, bring down x to the 5/3. Final answer. Then here you're dividing, so top to bottom, subtract the exponents where the bases are the same. So 3 to the 3/4 minus negative 6/4. Practice writing it out if you need to, because you should have seen two negatives making a positive. Then here, your base of 8, that's 8 to the first. So 1 minus 5, top to bottom. So here you have 3 to the 9/4, because again, 3/4 minus a negative. Then 8 to the not 4, because that's 1 minus 5, so negative 4. Then negative exponent here, so you have 3 to the 9/4 over 8 to the 4th power. Then here you needed to rewrite. So this is b to the 3rd power over your index of 8. Then here, power to a power, multiply. So that's 5 times 5/8, which is 25 eighths. Then again, dividing top to bottom, subtract the exponent. So that is b to the 3/8 minus 25 eighths, which gives you b to the negative 22 eighths, which, again, negative exponent, rewrite. So that is b to the 22 over 8. Now, for those who practice rewriting, that is 1 over b to the 22nd power, so b to the 22nd inside of your index, your radical 8. So then here for this one, you had to again rewrite, that's x to the 2nd power, so x to the 2nd power over 5. Bring down y to the 3/5 and x to the negative 1/5. So now you should have noticed you only added these two exponents here where the bases are the same. So this is x to the 1/5, then times y to the 3/5. Final answer, bases are different. So then here, the last here you've got, notice everything had a base of x. So we'll go through and add the exponent up top first. So now here you've got x to the 7 over 2. Then bring down x to the 5 over 2. So now here, now you can subtract the exponents because you're dividing. You should have gotten x to the 2 over 2 or x to the first power, which is just x, because it's understood, right? Remember to have that exponent of 1. So then our last here, you just have to remember that when we writing this fraction, the exponential, this is b to the 12th power, but it's a square root. So that index, remember, right, has a 2 here. So that's 12 over 2. Then b, that is b to the 3rd, but again, square root. So the index of 2. So now when you subtract the exponents top to bottom, that is 12 over 2 minus 3 over 2, which gives you 9 over 2. That's why here the answer is C.